The future of space travel beyond Earth's orbit. In a world increasingly defined by the rapid pace of technological advancement, one domain continues to inspire both awe and ambition: space travel. Once the domain of a few elite astronauts and robotic probes, the future of space exploration now promises a broader, bolder vision. Humanity's reach beyond Earth's orbit into deep space. With missions planned to the Moon, Mars, and even beyond, the future of space travel is no longer just about exploration. It's about habitation, innovation, and the next giant leap for humankind. The dawn of a new space age. The 20th century saw humankind take its first tentative steps beyond the cradle of Earth. The launch of Sputnik in 1957, followed by Yuri Gagarin's orbit in 1961, and the Apollo 11 moon landing in 1969, were defining moments in human history. Yet, after the Cold War space race cooled, ambitions shrank. For decades, low Earth orbit (LEO) became the primary domain of human spaceflight, with the International Space Station, ISS, serving as its centerpiece. Today, that paradigm is shifting. The 21st century has ushered in a new era marked by international cooperation, commercial innovation, and a reinvigorated vision of humanity as a multiplanetary species. At the heart of this transformation are ambitious plans that aim not only to revisit the Moon but to settle it, to send humans to Mars, and to ultimately push the boundaries of interstellar travel. The Artemis program and lunar colonization. NASA's Artemis program is the cornerstone of the United States' modern lunar ambitions. Named after the twin sister of Apollo, Artemis aims to land the first woman and the next man on the Moon and to establish a sustainable presence there by the end of this decade. Artemis I, an uncrewed test flight around the Moon, successfully launched in 2022, setting the stage for Artemis II, a crewed mission planned for 2025 that will orbit the Moon. Artemis III, expected by 2026 or 2027, aims to land astronauts near the lunar South Pole. This time, the Moon is not just a destination, it's a base. NASA, in collaboration with international partners like ESA, European Space Agency, Jaxa, Japan Aerospace Exploration Agency, and private companies including Spacex and Blue Origin, plans to construct the Lunar Gateway, a space station orbiting the Moon and Artemis Base Camp on the lunar surface. These installations will support long-duration missions and scientific research, test new life support and propulsion systems, and act as a proving ground for future Mars expeditions. The lunar South Pole is of particular interest because of the presence of water ice in permanently shadowed craters, an essential resource for drinking water, breathable oxygen, and rocket fuel. The ability to utilize in-situ resources, known as ISRU, in-situ resource utilization, will be a critical component of sustaining human life on the Moon and preparing for more distant voyages. The Red Frontier, human missions to Mars. Mars, the fourth planet from the Sun, remains the ultimate destination for human exploration. The idea of sending people to Mars has moved from the realm of science fiction into a legitimate strategic goal. NASA, SpaceX, and other international space agencies envision a human landing on Mars within the next 2 decades. NASA's Mars plans are methodical. Building on the experience gained from Artemis and the ISS, NASA aims to use the Lunar Gateway and Moon Base as a stepping stone. The Mars Sample Return mission, currently underway, is expected to retrieve Martian rock samples by the early 2030s. By the mid-2030s, a crewed Mars mission could be launched, lasting up to 3 years, including travel and surface operations. SpaceX, led by Elon Musk, is taking a more aggressive approach. Its Starship rocket, designed for full reusability and high payload capacity, is central to Musk's goal of building a self-sustaining city on Mars by the late 2040s. While the timelines are optimistic, Starship has already undergone multiple test flights and is considered a game-changer in terms of cost efficiency and scalability. However, the challenges of a Mars mission are immense. Astronauts will face extended exposure to cosmic radiation, microgravity-induced health issues, psychological stress from isolation, and the logistical nightmare of transporting and producing food, water, oxygen, and shelter. Nonetheless, the rewards of establishing a second home for humanity and unlocking the secrets of Martian geology, potential biology, and resources are incalculable. Commercial space and the rise of the private sector. The future of space travel is not the domain of governments alone. The rise of commercial space companies has revolutionized access to space and accelerated innovation. Companies like Spacex, Blue Origin, Boeing, Northrop Grumman, Sierra Space, and Axiom Space are developing spacecraft, habitats, and orbital platforms that complement and, in some cases, compete with governmental space programs. The ISS is expected to be retired by the end of the decade, and multiple commercial space station projects are already underway. Axiom Space plans to build the first private space station, with initial modules set to launch in the late 2020s. These platforms will support not only scientific research, but also space tourism, manufacturing, and entertainment. Commercial spaceflight has also enabled new business models. Suborbital tourism flights by Blue Origin and Virgin Galactic have already taken paying customers to the edge of space. In the near future, private citizens, researchers, and even filmmakers will have opportunities to visit space, democratizing access to the final frontier. Propulsion breakthroughs and interstellar dreams. One of the major bottlenecks in deep space travel is propulsion. Traditional chemical rockets are powerful but inefficient for long-distance missions. New propulsion systems, such as nuclear thermal propulsion, NTP, ion drives, and even experimental fusion-based engines, are being explored to dramatically cut travel time and improve payload capacity. NASA and DARPA are collaborating on the Draco project, a nuclear-powered spacecraft intended to reach Mars significantly faster than current technology. Meanwhile, Breakthrough Starshot, funded by billionaire Yuri Milner, aims to send gram-scale probes to Alpha Centauri using laser-propelled sails at a fraction of the speed of light, a bold step toward interstellar exploration. While interstellar human travel remains a distant goal, advancements in propulsion and artificial intelligence are setting the stage for robotic explorers to venture beyond our solar system within this century. Ethical considerations and the human factor. As we expand into space, ethical questions abound. Who owns the Moon, Mars, and the resources they contain? The 1967 Outer Space Treaty declares celestial bodies the province of all mankind. But commercial interests and geopolitical rivalries are challenging that principle. Moreover, the psychological and sociological aspects of space travel, living in confined spaces, long isolation, multicultural crews, and generational missions, require new approaches to mental health, team dynamics, and governance in space. The inclusion of diverse astronauts, such as women, people of color, and international participants, is also reshaping the image of space exploration and ensuring that the benefits and responsibilities of space travel are shared by all of humanity. Earth's new perspective from space. Perhaps the most profound outcome of expanded space travel is the shift in perspective it brings. Astronauts often describe the overview effect, a cognitive shift when seeing Earth from space, leading to a sense of unity, fragility, and responsibility. As more people venture beyond Earth's orbit, this perspective may become more common and could inspire a global reevaluation of our relationship with our planet and each other. Climate monitoring from satellites, asteroid defense systems, and even lunar-based solar power arrays are all examples of how space technology can help protect and sustain life on Earth. Thus, venturing into space is not an escape from Earth. It is a way to better understand and preserve it. Conclusion: a cosmic journey begins. The future of space travel beyond Earth's orbit is more than a technical endeavor. It is a cultural, philosophical, and existential leap. We are entering an era where moon bases, Mars colonies, and space hotels may become not just imagined possibilities, but lived realities. Driven by bold visions, technological breakthroughs, and a shared spirit of discovery, the next century could see humanity evolve from a planetary to an interplanetary species. As we push beyond Earth's orbit, we are not merely charting new worlds, we are defining the next chapter of our human story.